Okay, this is a review for the final for chemistry. There's going to be three parts to the final. The first one is stoichiometry. The second one will be the gas laws. And the third one will be the last thing that we just did, chapters 14 and 15. So stoichiometry shouldn't be that much of a stretch to review it because we have been working in a sense with stoichiometry over and over throughout the semester. But let me just hit the high points and let me just mention something on the final itself. I can't do what I would normally do, so there's only a few questions. It's very short. I need you to explain to me what you're doing, show me, even though you're typing it out, you don't have to use subscripts or anything like that. But basically, let me know what you're doing. If you just put down an answer at the end and it's wrong, you don't get any credit, and that's kind of a big deal. So let's start with stoichiometry. Stoichiometry is how we figure out either how much of something we're going to have or how much we needed to begin with. We can figure out what's called the excess or the limiting reactant. We can find the mass of the excess. We can find something called percent yield when we talk about how much of something comes out of an equation. But the basic idea of stoichiometry is we start with a balanced chemical equation. Let's just say we have calcium nitrate plus, let's say, potassium, and that gives, we call that a single replacement reaction. And this, because of that, we'd need a 2 here and a 2 here. The simplest stoichiometry problem would be where I tell you that you've got 20 grams of this, and how many grams of that are we going to come out with? So you would do 20 grams of calcium nitrate, change that to moles, as I would have said in class, we're counting it. This is what you would want to do on the test. You're not going to be able to show me this really, although you could write it out, 20 grams, and then put a times here. And that would be fine. I don't like that, but I don't know how else to do it on this. So then we would find what this is. This is 40, and this is 28, and 48, 16 times 3. Since we're reviewing, I will do that on this problem. We have nitrogen, 2 times 14, oxygen, 6 times 16, 40, 28, and 96. 164 grams of calcium nitrate. And now we put in the heart of stoichiometry, which is the mole ratio. We have 1 mole of calcium nitrate for every 2 moles of potassium nitrate. 2 moles of potassium nitrate. And then 1 mole of potassium nitrate would be 101 grams of potassium nitrate. You can check that out later if you want to, but that's what we would get. Now we multiply it across, and you all know how to do that. So 40 times 101 divided by 164, and you'd end up with 24.6 grams of potassium nitrate. First thing you have to do is balance the reaction and set this up. All right, let's say, though, instead they said we had 20 grams of this, and we have 15 grams here. And then the question would be, how much do we end up with? Well, in a problem like this, we have to check both of them because we don't know which one is going to run out first. And this then would be called a limiting reactant problem. If you were given both of them, we would have to go through this procedure. 1 mole of potassium is 39 grams. There would be 2 moles of potassium for every 2 moles of potassium nitrate. And I would do it with the lines, but on the test you could write it like that. 101 gram of potassium nitrate is 1 mole of potassium nitrate. And now this would be 15 times 101 divided by 39. And you would come out here with 38 38.64. 38 point, actually it's 38.8, I think. Can't read that. 38.8 grams of potassium nitrate. All right. Well, that means that this is the right answer. And what we would then say is in this problem, this is the limiting reactant. And this one is in excess. Or we'd call it the excess reactant. So that would be a second level on a problem to give you both of those and then ask what's the limiting reactant, calcium nitrate, what's the one that's in excess, the potassium, and then we could go one step further and I could say, I could then ask the question, how much excess do I have? How much extra potassium did I have? This is called the mass of the excess, or the amount of the excess. And in order to get the amount of the excess, what I need to do is go back to what I know is limiting, 20 grams of calcium nitrate. That's controlling the problem. 1 mole of potassium nitrate, calcium nitrate is 164 grams of calcium nitrate. Just like before, but now is where we're going to do something different. 1 mole of calcium nitrate needs 2 moles of potassium. And 1 mole of potassium is 39 grams. Now, if you still don't understand that, what happens is this number controls the problem. If I had told you 20 grams, you could have told me how much I need here. And it's not 15 grams. 15 grams is overkill. It's a waste. 20 divided by 164 times 2 times 39. Oops. And this ends up being 9.5 grams. In other words, I only needed 9.5 grams of potassium nitrate. Well, how much did I start off with? I started off with 15. So the mass of the excess is 15 grams minus 9.5 grams. 5.5 grams of potassium was in excess. In other words, if I had pad 9.5, we would have had the same answer on both of them. Another tack on would be to then stop at this point when this is all done and say, how much calcium is produced? Well, what a lot of students will do is do the whole problem again, but actually I now know that that controls the problem. So this would be 20 grams of calcium. 20 grams of calcium nitrate. We're going to go through the whole stoichiometry again. And 1 mole of calcium nitrate is that 164 grams. And there are 1 mole of calcium nitrate for every 1 mole of calcium, and 1 mole of calcium is 40 grams. Sorry, it's a little messy there, but, and then that would be 20 times 40 divided by 164. And we would end up with 4.9 grams of calcium. And by the way, if you added these up, 24.6 and 4.9, that would be 29.5. And if you took this, 20 and 9.5, it would be the same. We'd have the same thing on both sides. Now, there's one other part, and I'm just going to erase part of this. If on this problem, we started out, and I said, you have, and let's do this, we've got 20 grams of calcium nitrate, and excess potassium, but you run the experiment and you get 22 grams of potassium nitrate. The question will be, what is your percent yield? Well, percent yield is when we take the actual yield divided by the theoretical yield times 100. Well, in this case, the actual yield is right here. This has to be given to you. That's the actual yield. And this is our theoretical yield. The theory is our stoichiometry. So on this problem, it would be 22 grams divided by 24.6 grams times 100. And as we discovered, sometimes your percent yield can be more than 100%, simply because you may have some contamination. And what I get is 89.4%. So that is a very, very quick review of stoichiometry, a little 10-minute review. But like I said, we've been doing stoichiometry. Really, we did it several times throughout the semester. So go back and look at the test for chapter 9, which is where we did this, and then practice a little bit, and you should be good to go.